Hello everybody, welcome to the video. Today we're going to be going over polynomials and specifically how to classify them and adding and subtracting these polynomials. So to begin, let's go over some vocabulary. So these are going to be some terms that you have to be familiar with during these unit when we're going to be going over polynomials. So first thing is a constant, and basically what a constant is just a fixed number. So here's some examples. You can have 7 as a constant, 3,453,245, that's a constant, and pi, that's another constant, 3.1415, right? So that's what a constant is, as opposed to a coefficient, and that's a number that's multiplied by a variable. So here's some examples. For 4x squared, 4 would be the coefficient. So the coefficient, as you can see here, are labeled in red. And for the second polynomial, 10 would be the first coefficient, and -7 would be the second one. So that's the difference between a constant and a coefficient. A coefficient is next to a variable like this, but a constant is just kind of by itself. The third vocab word is a term. So what that basically is it could be a constant, just a variable, or the multiplication of both. So here's some examples. So you got 39 is a constant, x is a variable, and 5y to the 5th power is a multiplication of both. And these are all one term right here. These are all one term. Next, we have like terms, and those are terms that have the same variable and the same exponents. So here we have an example, 3x to the 3rd power and 5x to the 3rd power. Those would be like terms. Same with 4y and 7y. And I also wanted to show you some examples of things that are not like terms. So 5x and 4y are not like terms because they have different variables, and these two are not like terms because this has an exponent of 3 and that has an exponent of 2. So in order for them to be considered like terms, remember that not only do they need to have the same variable, but they also have to have the same exponents as well. So please keep that in mind. Okay, so next we want to define what a polynomial is. And just so you guys know, the prefix poly means many and nomial means name. So this kind of means like many names right here. And what this is a group of terms that have positive whole number exponents. So here's some examples of polynomials. These are 3 terms right here, and these are 2 terms, and these are both polynomials because all the exponents are positive whole numbers, okay? So here's some examples that are not polynomials. So the reason why this is not a polynomial is because it has a negative exponent, and square roots are also not considered polynomials either. So only whole number positive exponents are polynomials. Next, we have this notion of a degree, and all that really means is the highest exponent of a polynomial. So for example, in the polynomial that you see on the screen, 3 would be the highest exponent, therefore 3 would be the degree of that polynomial. And then lastly, we have this notion of standard form. So usually when you write out polynomials, you should write it from the highest exponent to the lowest. So this would be an example of something in standard form. Notice that you have to the 3rd, squared, and the constant right here. So it goes from highest exponent to lowest. And this would be an example of something not in standard form because the highest exponent is all the way over here and it's out of order. So that would be not considered standard form. So that's just some vocabulary terms you should know. So please keep those in mind when we do the unit for polynomials. Okay, everybody, so let's talk about how to classify these polynomials. And there's actually 2 ways to do these. The first way to classify polynomials is by degree. And remember, degree means highest exponent. So if the degree is 0, then it's just a constant, like for example 5. And the reason for that is because you can think of 5 as just 5 times x to the 0 power. That's going to be the highest exponent. And x to the 0, as you guys know, is 1, right? So this is just another way to write a constant. So if the degree is 0, then it's a constant. If the degree is 1, we call that a linear function. This is kind of like y equals mx plus b. So the example is there on the screen. If the degree is 2, we call that quadratic. If the highest exponent is 2, is quadratic. If the highest exponent is 3, that's going to be a cubic function. If the highest exponent is 4, we call that a quartic function. And if the highest exponent is 5, we call that a quintic function. Okay, so those are the different sort of classifications in terms of degree. The second way to classify polynomials is by the number of terms. So if there's just one term, that's called a monomial. So here's an example of that. 8 times x to the 9th power, that's just one term, that is called a monomial. And if there are two terms, we call that a binomial, as you can see on the screen right there. And if there are three terms, then we call that a trinomial, as you can see on the screen right there. If the polynomial has more than 3 terms, then it's just basically a polynomial with blank terms. So, for example, the way you would classify this is it would be a polynomial with 4 terms. 1, 2, 3, 4. So one easy way to remember how many terms there are in a polynomial is that they're separated by pluses and minuses. So here you have like plus, minus, minus. So here this is going to be 1, 2, 3, 4 terms. Okay, so that's kind of an easy way to remember it. So this is just kind of a summary of all the classifications here. So you can classify these polynomials by degree and by the number of terms, okay? And by the way, I forgot to write this down, but if the degree is higher than 5, like for example, if it's 7, we would just call that a 7th degree polynomial. That's what you would call it, okay? Okay, so let's just do some quick examples about classifying. There's no work to show here, you just have to know how to classify them. So if we want to classify this by degree and number of terms, you basically have to determine which one of these it is and which one of these it is. So to classify it by degree, remember degree means highest exponent. The highest exponent here is 2, so that's going to be a quadratic. And how many terms do you see here? There's 1, 2 terms. So it's a binomial. This polynomial is a quadratic binomial, okay? What about this one? We want to classify this polynomial by degree and by the number of terms. So can you guys figure out what it is? So the highest exponent looks like it's 4, so we call that a quartic. And since there's 3 terms, that's going to be a quartic trinomial, okay? That one is going to be a quartic trinomial. Okay, let's go over some more quick examples here. Let's say it's just a constant. Let's say it's just 8. Well, actually, I just kind of gave away the first one. But if it's just 8, if it's just like that, which is a polynomial, then it would just be a constant monomial. That would just be one term, okay? So that's going to be classifying this one. And then lastly here, we have x cubed plus x squared plus x plus 2. So this polynomial has 1, 2, 3, 4 terms, and the highest exponent is 3. So we call that a cubic polynomial with 4 terms, okay? Cubic polynomial with 4 terms. So in order to classify polynomials, just basically decide which one of these it is, depending on the highest exponent, and then which one of these it is, depending on how many terms there are in the polynomial. Okay. All right, everyone. So the last thing I want to go over is how to add and subtract polynomials. Okay. And the strategy is to basically just identify and combine all the like terms. That's what you have to do. Okay. So once you do that, it's just a matter of adding and subtracting the coefficients. So let's take a look at this quick example here. We have two, this is a binomial. It's, 2 monomials. And notice that they are like terms because they have the same variable, which is x, and the same exponent, which is 5. So to combine these, all we have to do is add the coefficients, which is 5 plus 3, and that gives us 8. So this is going to be 8 times x to the 5th power. Notice that I did not add the exponents. So you don't add the exponents when you work with polynomials. You just add the coefficients. So this would be 5 plus 3 is 8, x to the 5th power. All right. So that's going to be your solution for this problem. Okay, guys, one more example here for adding and subtracting. So here we have this example of 3v to the 4th power minus 3v plus negative 3v plus 5v to the 4th power. And so what we have to do here is basically just identify the like terms. So these two would not be like terms, okay? But what we can do is actually combine the like terms for both of these polynomials. So here we have this term, 3 times v to the 4th power, and this term, 5 times v to the 4th power. We're going to add these two, and we're also going to add negative 3v and this other negative 3v, okay? Those two are also like terms, and we're going to add them because that's what this does to do. So if you add 3v to the 4th plus 5v to the 4th, we're going to get 8v to the 4th, And then if you add these two, we have negative 3v plus negative 3v, and that gives us negative 6v, okay? So remember, guys, it's just a matter of, figuring out what the like terms are and then adding them, okay? And then adding them. Okay, everyone, so now that we've gone over adding, I want to go over an example of subtracting with you guys. So let's take a look at this example. So here, these polynomials are a little bit bigger, okay? But if we're careful, then we can figure out what's going on here. So here, it looks like we have a quartic polynomial with 4 terms, and the same thing here. It's a quartic polynomial with 4 terms. And notice that now we're subtracting, not adding. So what I would recommend if you're subtracting polynomials is to actually distribute the negative first, okay? So minus negative 6 is negative 6, minus negative 2 is positive 2, and so on and so forth. So distribute that negative sign first, so that way all the terms are right there, and then you can just identify which ones are your like terms, okay? So when the polynomials get pretty large like that, and you have to subtract them, that's what I would recommend that you guys do. So now we have to simplify this entire expression right here to get our polynomial. So we're going to begin actually with the highest exponent, which is 4, because we want to write this in standard form, from highest exponent to lowest. So the two like terms here would be negative 4 a to the 4th and 2 a to the 4th. So if you add negative 4 plus 2, you get negative 2. A to the 4th. Remember, what I mentioned earlier is that you don't add the exponents. It's just the coefficients, okay? So the next exponent after 4 would be 3. So these are the ones that have the exponent of 3. So we got 8a to the 3rd power minus 4a to the 3rd power. So then you got 8 minus 4, which gives us 4a to the 3rd power, all right? Then we have the exponent of 2, which would be these two right here. So negative 8a to the 2nd power plus 7a to the 2nd power would be negative 1a to the 2nd power, which can just be written as negative a to the 2nd power. And it looks like we don't have any terms with just the variable a. So we'll just move on to the constants, which would be positive 2 and negative 6. And then 2 minus 6 would be negative 4, okay? So that is the addition right there, okay? So as I mentioned, please write your final answer in standard form, highest exponent to lowest. And one thing that I would do if you don't have like different color pencils is to just kind of like cross out the terms that you have already combined, so to make sure that you don't miss any terms. But this right here, this strategy is pretty much how to add and subtract polynomials.